final test in the class, I'll admit, picks up a little bit early, so it includes some questions that were really meant for the test before, but hopefully some of these are somewhat easier and will help you out. I would say that you're going to want to have your calculator and your table of values with you when you do the test. Number one is fairly straightforward. It just asks me what the standard error is when I have a certain n and I have a sigma. When it says standard error of the mean here, what it really means is sigma sub x bar. If you remember our formula for that, it was the original sigma that's given divided by the root of n. So in this case, it tells me that the standard deviation of the population is 15. I'm going to put that on top. It tells me it's a sample size of 25, so I'm going to put root 25 on bottom. That's how I get 15 over 5, or 3 is my final answer. Number 2 is going to be a problem where they tell me a mean and standard deviation, and by using z-scores, I'm going to be able to find probabilities between, greater than, and less than. So in this case, a certain type of automobile battery is known to last an average of 1,220 days. That's going to be my mean mu, 1220. With a standard deviation of 175 days. That's going to be my sigma, 175. If 961 of these batteries are selected, n equals 961, find the probability. So remember that when we're finding these z-scores, our formula is going to be based off of z equals x bar, the average in question that we're trying to test against, minus mu, the population value 1220, divided by sigma, the population value 175, divided by the root of n, in this case the 961. So when we're looking between 1200 and 1220, there's two different z-scores involved. The first one is based off 1220 minus 1200 divided by 175 over the root of 961. The second one is z equals 1220 minus 1220. I'm sorry, I messed this up. This really should have been 1200 first, 1220 second. That's definitely an important distinction. Make sure you're doing the x bar value minus the mean. So this second one is 1220 minus 1220 over 175 divided by the root of 961. Again, I'm going to need to use my calculator for this. So when I put this first one in, I put it in as parentheses, 1200 minus 1220 divided by parentheses 175 over the root of 961 and parentheses. This first one gives me negative 3.52, or I'm sorry, negative 3.542. If I round to 2 decimals, I drop this 2 and I just get negative 3.54. The second z-score here gives me 0.00. When I go to look up the p-values, both of these are tricky. So, firstly, when I go to look up negative 3.54, it's off my sheet. I need to remember when something's off my sheet and negative, I call it a p-value of 0.0001. When something's off my sheet and positive, I call it a p-value of 0.9999. So in this case, off my sheet of negative, p equals 0.0001. For a z-score of 0.00, I really can look on either the negative or positive side. This means it's right at the mean. Right at the mean has probability p equals 0.5000. Since it's a between question, I take larger p-value minus smaller. So my final answer would be 0.5000 minus 0.0001, which gives me 0.4999. That would be the correct answer, to the average being between 1200 and 1220. For part B, it asked me when the average is greater than 1204. So I set up my z-score, 1204 minus 1220 over 175 divided by the root of 961. When I put this into my calculator, 1204 minus 1220. I get a z-score of negative 2.834. I'm going to drop this 4 and just call it negative 2.83. Had it been negative 2.837, for instance, I'd have to call it negative 2.84. Looking on my table on the negative side, negative 2.83 gets me to a p-value of p equals 0.0023. Since it says greater than, I take table value and do 1 minus. 1 minus 0.0023 is going to give me 0.9977. The average is less than 1199. I didn't choose great numbers here is the truth. I tried to make them up and make them work right, but really what's going to end up happening is it's going to be a little more negative than this, and I'm going to get a p of 0.0001. So I apologize that these numbers were a little further away from the mean than they should have been. But if I finish this out, z of 1199 minus 1220 over 175 divided by the root of 961. When I put that in, my calculator gives me negative 3.72. Again, this is so far negative that it's off my sheet. So really anything that's negative 3.49 or greater, we say has a p-value of p equals 0.0001. In this case, since it's a less than question, I don't have to do anything more to it. Just the table value is the correct answer here. The chance of me grabbing 961 batteries that are supposed to have an average lasting time of 1220, for them to have 1199 or less, is less than 0.1%.